Hello. So what if I ask you what is 5 into 2? That is 10, right? Simple. And what is 2 into 5? That is also simple, that is also 10. This property for ordinary numbers is called commutativity. So ordinary number follow this. But what if I tell you that the particles which form most of the matter, that are fermions do not like this property. What I mean is, in quantum mechanics there is something called coherent states. Coherent states are eigenstates of annihilation operator. So in quantum mechanics there are two types of operators, this A dagger and A. This A is the annihilation operator which annihilates a particle, and this is the creation operator which creates a particle. So suppose if we write eigenvalue equation for annihilation operator, say A alpha of eta, this will be eta alpha of eta. So this eta is fermionic state, and this is the eigenvalue equation for annihilation operator. Now this is the operator, and this operator follows algebra like this, which is A alpha and A beta. This anti-commutation is 0, and this anti-commutation, this means that A alpha A beta plus A beta A alpha, this is 0. Now operators can be thought of as matrices, so this is not as shocking. Now what happens if you use this property here, because this is the eigenvalue equation, right? So this is some operator operating on a state, and this gives you some number, this eta alpha is some number. What number, complex number, real number, we will see, because if you again act A beta here in this equation, you will get A beta A alpha on eta, and you will see that you will get eta beta eta alpha and eta, because this is just number and this A beta will act on this. And if you act this operator here, which is A alpha, this operator and A beta on eta, this will give you eta alpha eta beta eta, right? Now if you simply add these equations, then this left hand side will become this. If you factor out the state, this will become this anti-commutation of A alpha A beta and psi is equals to same thing here, which is eta alpha eta beta plus eta beta eta alpha. Now this is 0 by this property, which implies, because this is an arbitrary state, that this quantity should be 0. This quantity being 0 means eta alpha eta beta is equals to minus of eta beta eta alpha. So these are some number that if you multiply them in this order and if you exchange the order, you will not get the same result. The result will be the negative of the previous one. So these kind of numbers are called Grassmann. Grassmann numbers. So yeah, that was it.